Solving equations with variables on both sides. As we solve these equations, we're also going to look at some proofs and how you prove. One of the things that we're going to be looking at is these different properties. If you need to pause the video and to write down all these different properties, the addition property of equality, what it lets you do is add the same number to both sides of the equal sign. We will use these properties listed here and here, this whole list, when we go to prove our equations today. What's the subtraction property of equality? It says you can subtract the same number on each side of the equation. So again, by subtracting c from both sides, here you can see they subtracted 3 from both sides. Subtraction property of equality. If we are looking at the multiplication property of equality, it just says we can multiply by the same number on both sides of an equation. So x divided by 3, we can multiply by 3, and we would say that that is the multiplication property. A lot of times multiplication property is used. Sometimes you'll see, and our book does use it, as the division property of equality. That means that we can divide by the same number on both sides as long as it's a non-zero. Key reason we want to make sure it's always non-zero is that we want to remember division by 0 is, what do we say the answer is? Division by 0 is undefined. So if we are talking about that, what are some of these other properties? The additive identity, well, what number can we add? The additive identity property says that we can take a plus 0 and it will equal a. Any number plus 0 will equal what you started with. The multiplicative identity is that if we can take any number a times 1, it'll always equal what we started with. The additive inverse property says that if you add a number and its opposite, so we're adding a number and its opposite or its inverse, it will always be equal to 0. So an example would be 7 plus negative 7 would equal 0. What's the multiplicative inverse property? That tells us that if we take any number times its reciprocal, so multiplied by the reciprocal of that, it will always be equal to 1, which is our identity. So if we are thinking of that, that would be like taking 3 times 1/3 is going to be equal to 1. The distributive property, we've worked with that. That's eliminating our parenthesis. 2 times x plus 3, we can rewrite that as 2x plus 6. That was our distributive property. Definition of subtraction. When we look at the definition of subtraction, that means that anytime we have subtraction, we want to rewrite it as adding the opposite. So these properties are going to be used at the end of the lesson. You'll see at the end, last video, to prove, when we talk about proving things. So rewrite as adding the opposite. Some of the things we're looking at here are like terms. When we add our like terms, if we are looking at here, our like terms are the y terms. And here, if we are looking at like terms in each expression or equation, these would be our like terms. One of the things we're going to be asked to do as we are solving the problems is get all of our terms on one side, all of our like terms, and add like terms. The other word you're going to see in today's lesson is the identity. If 39 equals 39, we say it's an identity because it's always true. In y plus 3 equals y plus 3 is the identity because it's true for every value of y. Whereas x plus 5 equals 8 is not an identity. Why? Because when you'd solve that, x equals 3. Another one that is not an identity would be if we have something like x plus 5 equals x plus 8. And if we think of that equation, what you know to be true is that if you subtract x from both sides, anytime I'm subtracting x from both sides, I would have 5 equals 8. 5 is never equal to 8, and so this problem, x is equal to, there is no solution. which means there is no number that we can come up with that will make this true. So when we talk about an identity, what would I add to 25 to get 25? That's our 0, our additive identity. Multiplicative identity is 1. And in this equation, it just needs to look the same on both sides. We'd have negative 5x. Which one is not an identity if we are looking at these? The one that's not an identity should be D. As you look at these equations in column A, read through each one and think, is it always, sometimes, or never true? 5x equals 15. Is it true for every number? No, it's true for just some of them. X equals x minus 1. Well, this would never be true for any value because if you solve this, you'd end up with 0 equals negative 1. And when we look at our second equation, x plus x is actually 2x. And if 2x has to be equal to 2x, that is always true. When you solve an equation with variables on both sides, the easiest way to do is look at your two variables. We have 5x and 3x, and get the variable with the smallest, if we're thinking of the smallest number, which is 2x, and subtract that or get rid of that on that side. How do we get rid of 2x? We're going to subtract it. In a few minutes, towards the end of the video, I'm going to show you how we show our properties. This would be the subtraction property of equality. 3x plus 2 equals 14. As you look at solving this, some of you might start solving and subtracting 2 right away in that second step also. Again, 3x is going to be equal to 12, and dividing both sides by 3, x is equal to 4. I'll always try and keep my x power positive so I don't have to worry about negatives. This comes in the inequality unit where this really comes in. What if you have the grouping symbols? The first thing we want to do is eliminate them. So if we are multiplying this out, again, some of you might be writing this step, 2 times 5x minus the 2 times 1 equals, some of you might be able to go right away to 3x plus 33. How did we get that? Remember, we're distributing the 3. So here in our first one, we end up with 10x minus 2 is equal to 3x plus 33. I need all the x's on one side. My larger x is 10x, so I'm going to subtract 3x on both sides. Please make sure when you come to class tomorrow for your notes that you have this filled in. So 7x minus 2 is equal to 33. This is starting to work out rather nicely when we add 2 to both sides. Addition property of equality. 7x equals 35. And when you solve, dividing by 7 on both sides, the division property of equality, x equals 5. Now the last problem we didn't check, so we always want to make sure we do the check. 2 times 5 times our value of 5, x is 5, so 5 times 5 gives us 25 minus 1. The question is that the same as 3 times 5 plus 11? If we are looking at that, 2 times 24, is it the same as 3 times, and we are looking at this one, 16. When we multiply here, we would be looking at 48, and 3 times 16 also gives us 48, and it checks. The next two equations that you see here, I would like you to try solving them. We are going to look at those in class tomorrow. Remember, once you've eliminated your parentheses by distributive property, you are then going to follow the steps that we did the last couple days. Get all the variables on one side and all the numbers. So I'm going to look for 3A and 3B in your notes when you come into class. As we talked about that word identity, it says an equation is true for every possible value of a variable for the identity. And they give the example of x plus 1 equals x plus 1. It says an equation has no solution or no value that makes it, if there's no value that makes it true, like x plus 1 equals x plus 2 has no solution. Make sure if you need to pause the video as you look at this. The question says here, think about this. How can you tell how many solutions it will have. If you eliminate the variable in solving it, and it's either an identity with infinitely many or an equation with no solution. How do you know when there's one solution? When you find what that variable equals. If we are solving this one, notice that these two look exactly the same. So we would say that there are infinitely many solutions and the original is an identity. Whereas when you go to solve 9m minus 4 equals negative 3m plus 5 plus 12, you get 9m plus 5 equals 9m minus 4. If you subtract 9m from both sides, negative 4 will never equal 5, so this problem has no solution. As you solve your problems in this lesson, keep in mind, use the distributive property first, clear the decimals and fractions. Step 2, combine your like terms. Step 3, use your properties to solve. In step 4, use your properties to solve for that same variable, and then always make sure you check your solution. If we're trying to decide infinitely many, one solution or no solution, they kind of have you go through these steps, but I don't even know if you need to go through all of these. If we look at this first equation, which is here in 19, we would say 3y minus 5, we're going to add our like terms, is equal to 3y minus 9. Since these are not exactly the same, but the 3 y's would cancel, this one is going to have no solution. The reason it's no solution is negative 5 cannot be equal to negative 9. If we use the distributive property here, 2y plus 4 is going to equal, and we multiply here, 2y plus 4, which means there's going to be infinitely many solutions. Any number you pick for y is going to be true. Infinitely many solutions. The symbol for infinity is this. So sometimes if you want to write infinitely many solutions, I would take that also. As we look at this equation, we are looking at 2y minus 4 equals 3y minus 5. If we're going to solve this, we would get all the variables on one side. And what I already noticed is that I'm going to have a y variable. I would have 1y minus 5, which means if I'm solving for y, there will be one solution. You're going to be asked to do proofs in class. I'm going to take you through this one, and we'll hopefully even get to a second one. In this problem, we are looking at 4x plus 5 plus 6x equals 50. That is given. You're going to show the steps on the left side and show your justifications, which is what we had earlier, on the right side. Well, what happened from first line to the second line? We added our like terms. So we are going to say adding like terms. Next thing we're looking at, so our justification is adding like terms. The next thing we are going to look at is that we're going to take 10x plus 12, and we're going to subtract 12 from both sides. What lets us do that? The subtraction property of equality. Next step, and they kind of get, and some of these showing all the steps, even though you're really thinking, all right, I don't need to do that. 10x plus 0 equals, on this side, 38. Well, how did we get 0? By adding 12 and negative 12. Adding 12 and negative 12, that is our additive inverse property. So additive inverse property. If we look at the next step, 10x plus 0 would give us 10x. What lets us add 0 to any number and get what we started with? That is our additive identity. Next step, multiplying 10 times x. In order to solve that, we are then going to divide on both sides by 10, so that we'd end up with 1x equals 3.8. If we are looking at that, the reason we can do that is the division property of equality. I'm going to show you one more, the given, and I want you to think about how we're solving this. Try and come up with as many steps as you can. When I did this one, I got quite a few.